Okay, this is the second lesson in 2 lessons, second videos in 2 videos, dealing with differentiation from first principles. Now, we've been told an example to differentiate f of x equal to 3x plus 2. So the first thing we're going to do is we're going to write empty bracket. So f of empty bracket equals 3 empty bracket plus 2. Now we're keeping a very, very close eye on the formula, and indeed we should always write the formula right next to it, and we get marks for doing that. Now if you notice here, inside the bracket is x plus h, so we need an x plus h inside this bracket. So there's our f of x plus h, and inside this bracket x plus h. Now what we're going to do is we're going to expand it out. So f of x plus h is now equal to 3x plus 3h plus 2. Now the next thing it says that we have to do is that we have to minus f of x. But we already know what f of x is. F of x is equal to 3x plus 2. So my trick is I write underneath this f of x, and here I write 3x, and then I write the plus 2 over here. And now I'm going to follow the instructions, and the instruction says I've got to minus these two things. I've got to take them away. So on the left hand side I'm going to have f of x plus h minus f of x. And on the right hand side I'm going to do the takeaway. When I do the takeaway, the 3x and the 3x cancels. The plus 2 and the plus 2 cancels. So all I end up with is, on the right hand side, is the answer 3h. Now I'm going back and looking at the formula again, and in the formula it actually has here a division sign, and underneath the division sign it's saying divide by h. So that's what I'm going to write here now. I'm going to write a division sign, and underneath the division sign I'm going to do divide by h. Whatever you do to one side, you do to the other. And now I go to the next line. I've got f of x plus h minus f of x all over h is equal to 3. Now I've got one small part of the formula still to do. One small part of the formula. And the small part of the formula that I've still got to do is the limit as h tends to 0. Now just highlight that formula so that you can see what I'm talking about, is I haven't used this aspect of the problem yet, which I'm going to use now. So I'm going to write in here, let h tend to 0. Well, on the right hand side, if I let this thing here tend to 0, according to the formula, if I let it tend to 0, it becomes dy dx. So therefore, on the right hand side, I now have dy dx. On the left hand side, all there is a 3, there's no h's. So the answer is dy dx is equal to 3. And that's the end of the first example, differentiating from first principles. This is a slightly more complicated example, but we do it the same way. What do we already have? We already have the f of x part. What do we need to get? We need to get the f of x plus h part. So we are going to do an empty bracket. So f empty bracket equals 3 empty bracket squared plus 2 empty bracket minus 6. So wherever there was an empty bracket, so wherever there was an x in the problem, wherever there was an x, we've gone back to second year work and we've actually replaced wherever there was an x with an empty bracket. The numbers, the powers, everything else stays the same. What goes inside that empty bracket? Well, what goes inside that empty bracket is the x plus h. So here we're now putting in x plus h, x plus h, x plus h. Go to a new line and work it out. F of x plus h is equal to 3. Now I have to work out what's inside the bracket. I can go off to one side and do it, which is what we would normally do over here. I'm going to do the expansion of x plus h all squared, but x plus h all squared is just x plus h on x plus h. X on x is x squared plus hx plus hx plus h squared. And that simplifies to x squared plus 2hx plus h squared. So I've now worked out this bracket here, and the answer is x squared plus 2hx plus h squared plus 2x plus 2h minus 6. We have expanded the second bracket. More working out. F of x plus h is equal to, multiply out the bracket, 3x squared plus 6hx plus 3h squared plus 2x plus 2h minus 6. So we've now finished doing the green part of the formula. What we're going to do now is we need to do the f of x bit. So underneath this, I'm now writing f of x. And f of x, go back to the question, is equal to 3x squared plus 2x minus 6. So I'm going to write the 3x squared underneath the 3x squared. The plus 2x, I'm going to write it underneath the plus 2x. And the minus 6, I'm going to write it under the minus 6. Because the formula says that we have to minus these two functions. So I'm going to put a minus sign here and a minus sign there. So working out the left-hand side, I get f of x plus h minus f of x. And on the right-hand side, because the way I've written it, it makes it easier, 3x squared minus 3x squared cancels. 2x minus 2x cancels. Minus 6 minus minus 6 cancels. So when I finish cancelling everything out, what am I left with? I'm left with 6hx plus 3h squared plus 2h. 6hx plus 3h squared plus 2h. What's the formula then tell me to do? It tells me to do a divide symbol and then divide by h. So there's my divide symbol and there's my h. So on this side there's my divide symbol and there's my h. Tidy up line. F of x plus h minus f of x is over h, and that's going to be equal to, now we're going to split this up into its partial fractions, 6hx over h plus 3h squared over h plus 2h over h. When we split it into its partial fractions, what we now notice is that the h on the bottom cancels with the h on the top. The h here cancels with one of the h's on top, and the h here cancels with the h. So we end up with a new tidy up line. So the new tidy up line is f of x plus h minus f of x all over h is now equal to 6x plus 3h plus 2. Now we go back and we look at the formula one more time. I might just bring this formula down so we can see it. So I'm going to bring that formula down. We can actually see it for the next part of the problem. What have I done? Well, let's tick off what I've done. I've done the f of x plus h. I've done the minus sign, the f of x, and I've done the division symbol, I've done the h. So the only thing I've still got to write down is the limit as h tends to 0. So what we're going to do now, I'm going to do that in red. I'm going to say let h tend to 0. Now what you've got to remember at this stage is when you let h tend to 0, this item on the left-hand side becomes dy dx. When h tends to 0, then this f of x plus h minus f of x all over h becomes dy dx. So that becomes dy dx. And we're letting x tend to 0. Because we're letting x tend to 0, the plus 3h becomes 0, and then you have plus 2, and the answer is dy dx is equal to 6x plus 2. And we finished. The next example involves a negative x, and it's the same story as before. We're going to do f empty bracket, start off. So f empty bracket is equal to minus 2 empty bracket plus 5. What goes inside that empty bracket? Well, what goes inside that empty bracket is x plus h. So now we put in here x plus h. Now we expand this out. So f of x plus h is going to become minus 2x minus 2h plus 5. And then you've got to learn that we then go to here. So we write f of x underneath it. So there's f of x. And what does f of x equal? We go back to the original question, and f of x is minus 2x plus 5. So there's minus 2x. Remember the trick, we write them underneath their corresponding values. What are we doing now? According to the formula, we're minusing on both sides. So when I minus on the left-hand side, I get f of x plus h minus f of x. And when I do the minusing on the right-hand side, then what we have is this cancels with this, and the plus 5 cancels with the plus 5 because they're like terms, and when you take them away from each other, they become 0. So we're just left with minus 2h. Now over here it says divide by h, so we're going to divide the left hand side by h. If we divide the left hand side by h, we're going to divide the right hand side by h. And again, more cancelling. The h on the bottom cancels with the h on the top. Then rewriting this line, we get f of x plus h minus f of x all over h is equal to minus 2. Don't forget this last part of the formula. The last part of the formula is let h tend to 0. Let h tend to 0. That's how you say it. Let h tend to 0. So let h tend to symbol is an arrow to 0. So what does the left hand side become? We know the left, when we let h tend to 0, the left hand side becomes dy dx. And the right hand side, well, there's nothing there except a minus 2, so it's minus 2. Which we already knew by differentiating the function in our head, but when it says first principles, we have to go through this process or we won't get any marks. You're pleased to hear this is now the last example. But every example we're doing is exactly the same, because when you're given the function f of x, what's the first thing you always should do? You should always do the empty bracket. So there's my f empty bracket equals 5 minus 3. There's an x, so therefore now putting an empty bracket, minus 2, and then there's an empty bracket, and that's going to be squared. So we've changed this function into an empty bracket function. But what goes inside the empty bracket? Well, we've seen it now on 3 occasions. What goes inside the empty bracket is the x plus h. So the x plus h goes inside each of these brackets. So here we go. So we put x plus h, x plus h, x plus h. Tidy up line. F of x plus h is now going to equal 5 minus 3x minus 3h. Minus 2 on. Right, put a bracket because I need to work out this answer and then substitute the answer in there. So I'm going to be squaring x plus h, so it's going to be x plus h on x plus h, and the answer, this is going to be x squared plus 2hx plus h squared. I skipped a couple of lines. Please work through it and make sure you can get the same answer that I can get. So in here we've now got x squared plus 2hx plus h squared, close bracket. So now we're going to tidy it up. F of x plus h is now going to be equal to 5 minus 3x minus 3h minus 2x squared minus 4hx minus 2h squared. Double check and make sure you've got it right. And now you move on to the next part of the problem. The next part of the problem says that you have to write down an f of x and then take it away. So I'm now going to write down f of x underneath this. So I've got f of x, and what does f of x equal? So I go back to here and look. So it's equal to 5, and I line up the 5 under the 5, minus 3x, and I line the 3x, minus 3x under the minus 3x, and a minus 2x squared, which again I line up under the corresponding value. And what are we doing? We are minusing. So I'm going to be doing a takeaway on both sides. The left-hand side becomes f of x plus h minus f of x. Now, what does the right-hand side become? Well, because they were like terms, when we do the takeaway, they disappear. Because these are like terms, when we do the takeaway, they disappear. And when we do like terms, when we do the takeaway, that disappears. So what are we left with in the end? We're left with minus 3h minus 4hx minus 2h squared. The next part of the formula tells us to divide by a h. So whatever we do to one side, we will do to the other. So we're going to divide both sides by h. So divide this side by h, divide that side by h. And then we do the tidy up line. So f of x plus h minus f of x all over h is equal to minus 3h over h minus 4hx over h minus 2h squared, which is hh over h. And then once again we go looking for the cancelling, and the h will cancel with the h will cancel with the h, and the h here will cancel with one of the h's. And once again we have to do a bit of tidying up. So we've now got f of x plus h minus f of x all divided by h is equal to minus 3 minus 4x minus 2h. Now the formula, I've got a copy of the formula here. We're down to the very, very last bit now, and the very, very last bit asks us to take the limit as h tends to 0. Take the limit as h tends to 0. So we're going to let h tend to 0. You must have that line in. If you don't, you will lose 3 marks. Kindly remember, on the left-hand side, if h tends to 0, then the left-hand side now becomes dy over dx. The right-hand side, well, there's no h in this, so it's just minus 3. There's no h in this, so it's minus 4x. There is a h in this, but h is tending to 0, so minus 2h will also tend to 0. So one last line, we can now say, therefore, dy dx from first principles is equal to minus 3 minus 4x. And finally, this is the exercise 13.2 I want you to do. I've marked the questions already. It's question 3 is what I want you to focus on. There aren't many questions, just make sure you learn it and you can do it off by heart. Make sure you learn the formula. Thank you.